when we look at the periodic table, we had it set up, when we did the periodic table, you guys took 20 elements, eventually it was 20 elements, and you arranged them in some order based upon what's called periodicity. Periodicity just means repeating patterns of some different things. So, again, you don't have to write this down, okay? But when you guys put this together, I didn't give you 1 and 2. Okay, that would be hydrogen and helium. Okay, I didn't give you that. What I did, I just gave you 3 and 4, and so you had 3 and 4. And then, if you kept on going, you got 5, 6, 7, 8, 9, 10. And you looked at, the row was the chemical property, if you guys remember that. It was, the row was the chemical property that you looked at. And then I think we finished up on these last 2, and that was 19 and 20. So basically what you guys had, you had a continuous row, 3 through 10, 11 through 18, and 19 and 20. And what was common in these rows was this chemical activity, right? That when you looked at this one, I think it was like, this one was like 1 to 2. 1 to 2 ratio, and in that one it changed like 0.5 to 1 and so on and so forth, but that's what you looked at. And so then you got all these other elements that had to be placed in the periodic table. All these other elements that we had to take an account for was in here. And I only gave you the first 20. So we know that the columns are arranged by their reactivity, how they react. And we know going across, we know it increases a little bit at a time going across. Don't put me out here. I'm teaching. And so the columns were chemical characteristics. So all of this column has the same characteristics all the way down. In a lot of aspects, chemical. These are all reactive with, we'll take a look at them later on, but these all are so reactive, like the guy in the video was saying, that they have to be put in an oil or into an inert gas that doesn't allow them to react. These are called the alkali metals. You never find them by themselves. You never find sodium, even though sodium is, we hear of a lot, but it's in a different form than the sodium that's here. This is pure sodium or pure potassium and lithium, this whole group. And they're extremely reactive with oxygen and with water. You put them in water, they start on fire. Okay? And I'll show you that later on when we start going through the families and that a little bit later on. This is called the alkaline earth elements there. And they're less reactive than alkali metals, but they're fairly reactive. They still kind of react with water. A couple of them do. They're very flammable. You get over to this last group. If you notice, this is the group that had the blanks for chlorine. They had blank chlorine, blank oxygen. Well, what that means is that whole group, which is made up of helium, neon, argon, krypton, none of them react with anything. So if you're wanting to put something in there that's really reactive, you put it in with these helium, neon, argon, and they'll keep them safe because they're not reactive. Where this one next to it is very, very, this group here is very, very reactive. They're gases, they're poisonous in the pure form. They're really nasty stuff. Okay, chlorine gas, you don't want to have anything to do with it. You breathe it in and your lungs start to explode. Actual pockets of your lung would actually cause them to react and explode, okay? Destroy them. So that's when we had that chemical warfare and like, they still do. But when they started it in World War I, that's what they would use as chlorine gas. And the chlorine gas is heavier than air, so they'd have to have a prevailing wind that would take the gas, when they opened up the valves, over to the enemy, and the enemy were in trenches. You guys remember studying some things about World War I? They had a lot of trench warfare where they went from one trench. It was just a little bit at a time. And that's one way. And they had to have the masks. that when they started smelling that, they had to get those on right away, because if they didn't, it'd kill them, because it would just mess up their lungs so bad. Okay, questions?
Where's ammonia at on there?
Now ammonia's not on there. Ammonia is made up of nitrogen and hydrogen, so ammonia is a compound. So its combination is pretty potent too. Yep.
I remember. I have questioned this before. So
Yep.
the 9 and 17 has the same chlorine and oxygen as 1, 3, 11, and 19 that they on the paper.
They combine the same way.
Yeah.
Yeah. So,
Okay.
and that's fine. They can combine the same way, and then if they do, you kind of look at some other characteristics too. So you would look at boiling point and melting point to kind of keep them in their rows and keep them, because that's just a small reactivity. They can look at other things too. So, yep, they can. There's not too many that have the same characteristics down, but there's a couple of them that do. Okay, so that's based on periodicity. We kind of know a little bit about that, and then there's some terms that you guys wrote down. So what are some of the terms that we wrote down that we talked about that we can just review real quick? So down below, what are some of the terms that you guys had to do? Oh, subatomic particles, right? Do you have those? Proton, neutrons, and electrons? Or not? You do?
Yeah.
Okay, protons are what? Positive charge. Where are they found? Nucleus. Neutrons, neutral charge, no charge. Okay? So if you go into a bar, you want to be with a neutron because they're never charged. Right? So find a neutron, you'll be in good shape. Right? You won't spend any money. And then electrons are what? Negative charge. Okay? And they counteract one another. So you'll have equal amounts of both. Okay? Because most of the time the atom's neutral. Not all the time, and we'll see some times where they're not. Okay? So, down below that, there's some more information that we talked about yesterday and you guys wrote definitions for. What's the atomic number? It indicates the number of protons. Is it on the periodic table? Yes. Is it a whole number?
Yeah.
Yes, it's that number that used to identify the atom. It increases by 1 across the periodic table. Okay, the next thing that you had was mass number. Yep, it's the protons and neutrons added up. And it kind of gives you an idea of the mass. That's why they call it the mass number. Because what makes the mass of the atom up is the protons and neutrons. They are what cause the atom to weigh what it does. Okay? So it's called the mass number. And so the bigger the mass number, the bigger its weight. Right? Because it has more protons and neutrons. And then the last one is atomic weight. Or maybe it wasn't the last one, but atomic weight, what is that? The average mass of sample of atoms for an element. So it's the average weight. Now you guys did an average weight yesterday of the pennies. So in a way you kind of did that, but with a much smaller sample. And you had two different types of pennies. One that was 2.5 and one that was 3. And your average came in between the two. So when what they do is they're able to find the percentages of all these types of atoms that make up a particular element. I'm going to show you a couple today so that you can see an example of what you did. Oh, you do have an example on the back of the penny lab. You guys, why don't you get that and I'll share the answer for that one. So in the back of the penny lab there were 4 different types of atoms. Okay? So on there you had chromium 50, and chromium 52. There's no 51 that has a very high. There might be a 51, but it doesn't have a very high percentage. Okay, it's super low percentage. Not big enough to even add into our total. And so these are all the type of atoms that chromium has. And so this one is 4.35% of a sample. So about 4 out of 100, I would find a chromium 50. This is 83.79. That means about 84 out of 100 would be like chromium 52. There's about 10 out of 100 chromium 53, and there's only about 2 out of 100 that would be chromium 54. So what you guys did is you multiplied these out, but when you multiply them out, you have to multiply by 0.0435, 0.8379, 0.0950, and then 0.0236. And then you got your answers. Then when you add those all up, I'm not going to share those with you, but when you add them all up, then if you look at the periodic table for chromium, it should come up to be 51.996. Or we could say 52. If we rounded it, it should be 52.00. Did you guys get that? Okay, if you didn't get it, okay, you're going to go ahead and you're not going to multiply by 50, but you're going to multiply by 49. This one's going to be 49.946 that you're going to multiply. And then this one's going to be 51.941. And so on and so forth all the way down. And then when you add them all up, at the end, that's what you get. Okay? So it's just a way to find the average based upon percentages. Okay. So we know these terms. We know protons, neutrons, and electrons. We know mass number, what that is. We know atomic weight a little bit about that. What that's going to be the average, and that's what we're finding here. I'm finding, what's the weight? It's called AMU. We won't get into what AMU would be. So let me share with you a little bit about a model of an atom. So let's just take a simple model. Let's take carbon, for example. Okay? So here's carbon. You're not going to have to draw these out ever. But it's always nice to have a little bit of a model to kind of go off of. So last year you probably put together some of these models. And when you put them together, the models, you had maybe protons you'd indicate here in the middle. And then I'm going to go ahead and put the protons in there. Okay, for this one, all right? And then you're going to have neutrons in there. So I'm going to put neutrons as blue. So you're going to have neutrons in there. Okay. And then on the outside, here, you're going to have electrons. Have you guys seen a model like that before?
Yeah.
Okay, so that's not foreign to you. Now, we don't want to draw models out every single time we describe some of the characteristics that we would have for a particular atom. Okay? So what we're going to do a couple of these, and then kind of see how it fits into what we're going to do here for the rest of the day and then tomorrow. Okay? And this is going to be this. So I'm going to ask you, how many protons are in this model? You guys see 6? Okay, yeah, they're bunched up, but there's 1, 2, 3, 4, 5, 6. So there's 6 protons. Alright, so all we're doing by me putting P++, that's a symbol for protons, I'm just telling you how many I have. That's all I'm doing. Okay, so then I count how many electrons there are. How many electrons?
8 electrons.
Alright, so this one there's 8 electrons. Okay, most of the time they're going to be they're going to be the same. But in this case they're not the same. So there we have 8 electrons. Okay? How many neutrons do we have?
6.
6 neutrons. Okay. So then there's some calculated values that I can do that that I can come up with some different ones, different numbers. Okay, one of those is going to be what's called the mass number. So remember, what's the definition of mass number?
The total number of protons and neutrons.
Okay, so what's the total number of protons and neutrons?
12.
12. Anybody have a question how you find mass number? You add protons and neutrons. Okay, so it'd be 12. Okay, another one you're going to have to do is going to be this thing called charge. So what's the overall charge? Well, if they're equal, if the electrons and protons are equal, what would be the charge? Be 0. Does that make sense?
Yeah.
We have 8 electrons. They are a negative charge. We have 6 protons. It's a positive charge. What is the charge of this atom?
-2.
Negative 2. Anybody have questions how we come up with a negative 2? If we have 8 negatives and 6 positives, we've got 2 more negatives. So that's why it's a negative 2.
How'd you get 12 for the mass?
For the 12,
Yeah.
it's the protons plus the neutrons. So the neutrons here. There's 6 of those. So we have 6. We have 6 protons, 6 neutrons, and so that's a mass of 12. You just add them up. Any questions on that? That's all you do. The mass number just represents how heavy it is. Okay? So now I'm going to make a copy of this. You guys don't have to copy this down. This is visual and that. So I'm going to go ahead and make a copy of this. Okay. And I'm going to change something up on my copy. So this is what I'm going to change. Okay. So how is this atom different from the atom before? So I should erase all of that stuff up here because it may change. It may not, but it may change. Okay. So what I always like doing is what I know. So what do I know for sure when I count them? How many protons do I have? 6. The proton number didn't change, did it?
No.
It's the same atom. It's carbon. The 6 indicates what atom we're talking about. So you look on the periodic table, and I have 6 protons. The number of carbons did not change. How about the electrons? How many do we have?
6.
So we have 6 of those. So what's the charge then?
0.
0. Okay, so it's 0. Now, if I want to know the neutrons, then I can count them.
7.
And I've got 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. So I have 8 neutrons. What's the mass number then? 14. What element is it? When you look on the periodic table, what element is it? So have your periodic table out. So what element are we talking about here?
Silicon?
Nope. Nope.
Where do you see? Oh, is it the?
Now look on your
Nitrogen.
notes. Look at your notes where it talks about this thing called atomic number. What's the atomic number represent?
Number of protons in the atom.
Number of protons in the atom. Look down on your key, bottom key. Find the atomic number. So what's this element? Carbon. Okay, so this is element carbon. Okay, what is this element here? Oh, I got the wrong one.
Uranium.
Yeah, what's this element here? Carbon. Okay, what's different in the two?
The amount of electrons and neutrons.
Amount of electrons
And the charge.
and the neutrons. The neutrons are 6 in that one, and over here, that one's 8. This one has a mass number of 12, and this has a mass number of 14. They're the same atom, but with a different weight. Other than the electrons. I should have made the electrons the same, but I messed up. Okay? So, all we have to do is, now we can kind of see an atom, and I'll give you 4 and 5 as well. So if you got 4 and 5 done, I'll write those down. That way you can see how you did on them. So that would be the answers for the first 5.